Hi guys, this is Dr. B. This is just a video to show you about the chi-square test and how to use it. Hopefully you've done a couple other videos first. This is just more of a refresher from those, so you want to watch the other Edpuzzles first. As far as you're concerned, chi-square is a statistical test that we use to compare sets of data to see whether they're related. And so we can use this particular example I just randomly grabbed from the internet to test the idea of it. So we can see here that we want to see whether this data fits the 9:3 to 3:1 ratio. And if we have, we can see here that we have a total of 556 offspring with a ratio of 9:3 to 3:1 of all of them. So we can be able to figure out kind of how many of them would fit into each category. So if we know that this is, by the way, 16 different values here, 9 plus 3 plus 3 plus 1, there's 16 different classes. And in this case, the first one right here, if we take a look at this, we expect 9 out of 16 of them to fit into that particular category. So 9/16 of 556. So if we take 9/16 as a percentage, we basically get 0.5625. So that's basically 56%. So all we would do in this case is we would take 556 times 0.5625. And when I put that into a calculator, I get 312.75. So I get 312.75. And you can see here that's exactly what they did. And then they figured, all right, well, what about 3/16? So again, in this case, we would take, if you want to do this mathematically, 3 divided by 16. And 3 divided by 16, if we just 3 divided by 16, if we throw that into a calculator, we're going to get 0.1875, which is 18.75%. So basically, what's 18.75% of 556? And if you do that, just like it's done above, you're going to get 104.25 in the other class. So it accounts for that. We did these two. This one's obviously the same, 104.25. And then 1/16 times 556 give us 34.75. Now, you can't have 34.75 wrinkled green peas, but this is a statistical test. So the idea, the whole entire point of chi-square is we expect to get these values, but we actually got these values. Are these close enough to these values to say that they're the same or close enough that we can't say that they're different? So now we need to basically do the test. So to do the test, we have to go ahead and choose our correct formula. And of course, it's chi-square, by the way. That's not an X, that's a Greek letter chi. And anytime you see this little thing, that means sum of. So basically, it's the sum of all the observed minus expected. And then we square that all over the expected. And we do that for every single category. This is a category, so we have one of them, 2 of them, 3 of them, 4 of them. So we're going to end up with 4 chi-square values and we're going to add them together. So let's just concentrate right now on this one right here. So what we're going to do is we're going to take chi-square equals, and of course for the first one here is observed minus expected. Well, what do we observe? We observe 315 and we subtract that from what we expect to get, which is 312, right? Well, that's not 3 point. Let me go ahead and erase that. There we go. I'll bend it around there. 312.75. And we square that value. And then we take that all over what we expect to get, which is 312.75. And if I just take that little information right there and I plug it into my calculator, I get a chi-square value of 0.016. 0.016. So that chi-square is just for the first, right here, the first group. And when I repeat that exact same process for the other ones, I'm basically going to add all of them together. So again, if I do chi-squared for the second category, it's going to be 108. Actually, I should say the value of 108 minus 104.25 squared all over 104.25. And then for that particular answer, I'm going to get 0.135. And now I don't really, so that's the second class. I do have to do the third class again because I have a different value right here. So the chi-squared for the third class is going to be this time 101 minus 104.25 squared all over 104.25. And then that particular value, after I plug that in my calculator, is 0.101. Then if I take the last one, let's go ahead and take the last value real quick. We see we have 32, right? So obviously I know it's off a little bit, but down here. We have 32 minus, and we expect to get 34.75. 34, forget that, that's not a dot. Actually, let me erase that. Oh, there we go, little erase. Okay, so 34.75 squared all over 34.75. And when I throw that in my calculator, I get 0.217. So 0.217. So now that I have all four of these, I'm basically going to add all of these together. All of these I'm going to add together right there. Boop, I'm going to add all of them together. And when I add all those together, the grand total of all this is going to be 0.469. Or we could also say 0.47. So the overall chi-squared is equal to 0.47. So you're like, what the heck does that mean? Well, we have to compare that to our particular chart to see where our chi-square value falls and compared to the rest of our significance. So if we take a look at this chart, this is the chi-square chart. It's a standard form that is used. We can figure out kind of what we're supposed to do here and what the values mean. So we have to take our number that we have, and of course we have, remember, our chi-square value is, our chi-square is, well, that's a terrible 2, is 0.47. So where we have to figure out where that is. So the first thing we have to do is, which of these particular rows are we going to use? Well, what we always do is we use what's called degrees of freedom. Degrees of freedom for this particular statistical test is n minus 1, where n is the number of classes. And if you recall, we had 4 classes. We had a class of 9, a class of 3, a class of 3, and a class of, whoops, not another one, of 1. So we had 4 classes. So if we have 4 classes, degrees of freedom is going to be 4 minus 1 is equal to 3. So we know from the chart, we're going to be going across at 3. Now, generally speaking, we use the 0.95, which is 95% confidence. It's something called a confidence interval. You don't need to worry about that for this particular class, but you'll learn it later. So we typically use this column. And what we're going to do is we're going to go all the way across until we figure out where our particular, let me erase this, where is our number in this whole thing? And our number, if you recall, is 0.47. So if I go along this route, I find that 0.47 is somewhere around here. It's somewhere between 0.35 and 0.58. And so because of that, here's the magic line here, right? There it is right there. If our number falls on this side, we have to accept the null hypothesis. And the null hypothesis is always the fact that the values that we're comparing, which is in our case, the observed, is equal to the expected. In other words, they're not statistically different. That's what the null hypothesis is. And right now you can see we have to accept the idea that the observed is basically the same as the expected because the numbers are so close together. And that's what the chi-square value tells us. Now, if we did a chi-square test and we happen to get, let's just say, a chi-square of, oh, I don't know, 9.63. In that case, if you go across, 9.63 fits in somewhere around here. And you'll note that it crosses that threshold that's right here into the reject area. And if that was the case, it means we have to reject the idea that these two values are the same. But because we found r chi-square on the left side of this, we have to accept the idea that both sets of values are the same. And the real big answer to this is finally that, yes, I believe that the values we got are because of a heterozygous dihybrid cross, which would cause a 9 to 3 to 3 to 1. So hopefully that helped. If you have any other questions, let me know.